Hello, all. Hope you're doing well. Today, in this lecture, we are going to discuss how to name different acids. So, if we come across these kind of acids like H2SO4, H2SO3, HNO3, HNO2, H2CO3, or we can take more examples H3PO4, H3PO3. So, which one is what? Sometimes it's very confusing to learn. So, in order to name these acids, we need to learn a trick, and before that, we need to understand the names of these radicals. Now, let's see this SO4 2 minus is something called as sulfate. Now, I'm linking over here if you can see this. SO3 2 minus is a radical polyatomic ion, we call it, and this is called as sulfite. Now, how do I remember all this? Now we need to remember that sulfur and oxygen together form a polyatomic ion, and you have to picture it in your brain that these are two ions. One is SO4 2 minus, another is SO3 2 minus. You have to map like that in your brain. Now, which one is what? Which one is sulfate? Which one is sulfite? So we say that the one which is having more number of oxygen atom relative to each other is something ending with the suffix ate. The one having less number of oxygen atom relatively compared to each other is ending with the suffix ite. So now these ate, they have something meaning. So if we have a radical ending with 8 or ending with ite, so 8, and we can even take ide. So that is going to change into a suffix ic acid. So we call this H2SO4 as sulfuric acid. Now, why is that? Because we have ate suffix. So ate radical will end into what acid? Ic acid. So if we go to the next one, ite will end into OUS acid. So that's why we call this as sulfurous acid. If you can see this. So SO3, 2 minus ending with ITE will end into OUS acid. Now we are going to see for all of these over here. Now HNO3, now we go to this NO3 radical. NO3 minus ion and NO2 minus ion. Again, you have to do the same activity in your brain. NO3, NO, and nitrogen and oxygen, if we talk about. So they are going to form two radicals. One is NO3 minus, another is NO2 minus. So we can actually, the same trick that you have to follow with over here, sulfate and sulfite. So which one is nitrate, which one is nitrite? The one which is having more number of oxygen atoms relatively is going to be called as nitrate, and the one which is having less number of oxygen atom, this is something called as nitrite. So again, ate will end into ic acid, ite will end into OUS acid. So that's why HNO3 is called as nitric acid, HNO2 is called as nitrous acid. Now we don't have any competition for this radical CO3 2 minus ion. This is just carbonate. We do have bicarbonate, but we are not using it over here. So carbonate CO3 2 minus ATE will end with carbonic acid. Now coming to this one. Now we have two radicals of phosphorus and oxygen, anion. One is PO4 3 minus, another is PO3 3 minus. Now the best part of these radicals, obviously the charge, collective charge on them is dependent upon their bonding. That we can discuss in the future someday, but not over here. So now if you can see nitrate and nitrite, they both have collective charge -1. I'm just trying to make you point out this part so that it's easy to remember. Sulfate and sulfide both have 2 minus charge, if you can see. Similarly, phosphate and phosphite, they both have 3 minus charge. So it's at least easy to remember that at least both of them have the same charge, collective charge. So this is phosphate, again due to the same reasons which I've told you before. And this is phosphite. So 8 will end into ic acid. That's why we call it as phosphoric acid. And then we have phosphorus acid. There are many acids of sulfur and phosphorus, but I took only simple examples just to create a link over here in this class. So thank you for listening to me.